Okay, welcome back to previous class. Now we will discuss this seeing of both figures. Okay, we are going to giving input. Okay, and response will be there. After that, the error will be there. It will find out that it will delete that or it will eliminate that errors, and then it will send to that controller. After that, it will goes to that signal to that actuator, and in that actuator also it will be boosted, and after that entire that signals is going to be processing out, and we are going to sending actual output. What is the correct output we are going to sending? If that after processing also we are going to taking feedback, and we are going to giving to that signals to that feedback to the sensor, and we are going to sending to that measurement output to the error instrument. So over there also again we are going to eliminating that with the help of feedback. Finally we are going to sending before sending of actual output. Okay, that is a system. So this is called as closed loop control systems. And one more thing, you can see that both the differences, you see that controller it will take, there is no feedback, elements. So actuator will be there and it will actuate that signals, means some of the signals we are going to boosting up and then process it, and we are going to giving to the output. This is open loop control systems. So now we will see that what is the difference between that first figure and the second figure. So what is that? So here is feedback is there, here is not feedback is there. It is time bound control system. It is a time bound control system, as well as with the help of feedback system, the system is going to be worked out. Okay, now we will see that differences of that systems. Now we will see that differences of the system. So what is that closed loop system and open loop system? And we will see that both. First, open loop control systems, we will see that. So it is not possible to use inaccurate components. It is not at all possible. Okay, open loop control systems. Okay, whereas closed loop control systems, the output changes with the help of feedback element. Here there is no feedback, so it we cannot give that actual output. So in open loop control systems, output measurement not required for operation system. So yes, 100%. It is not, it won't see that output, but it will work out. That's it. Okay, here output will see that measurement and it will give that output to that instrument. So feedback element is absent, feedback element is present, error detector is not there, but here error detector is necessary. Okay, it is unreliable. Yes, we can't trust on that open loop control system. We can trust on that closed loop control systems. So sensitive to the disturbances. So very less sensitive is there in that closed loop control systems. Okay, over there here bandwidth is very small, bandwidth is very large comparatively with the open loop control systems. Okay, environmental changes will be there. It is highly sensitive for open loop. If environmental changes will be there, it will work out very less sensitive. Okay, and constant, and it is very cheap and constant. Okay, it is complicated. Closed loop control systems, it is very complicated compared to that closed loop open loop control systems. So generally it is stable in nature. It is not stability is when considering the design, stability is the main important factor for closed loop system. Okay, highly affected for non-linearity systems. It won't be non-linearity systems, it won't be affected. So it is reduced of non-linearities. Okay, these are the differences of the closed loop and open loop control systems. Now we will see that another best examples. We will see that what is that main difference. So an open loop system has the ability to perform accurately, okay, and calibration is good. There is no doubt the calibration is good comparatively closed loop system, okay, and performance we cannot give that performance it is not good comparatively closed loop system, whereas closed loop system the performance is very good. Open loop control systems we can easily we can build, but over there closed loop systems we cannot build easily. It is very complicated to construct, to design everything. So generally that more stable and there is no feedback element. So I am going to summarizing this differences. So less stable and comparatively. So feedback is absent. So what are the examples I told? First one is the traffic control systems. Control of furnace for coal heating. We cannot, there is no, so that heat is going on. So electrical washing machine. The best example, traffic signals and electrical washing machines, control furnace of coal heating. So whereas feedback element is present in closed loop, what are the examples means? Pressure control, speed control, robot control, temperature control. Everything will be there in closed loop control systems. Now we will see that open loop control system and closed loop control system. Just one example I am going to taking, and I am showing that diagrams. Control unit will be there. From control unit to that speed of the car I discussed in the first slide. So control unit, after that it will come to that driver, and the driver will notify, means processing. After that it will go for motor. So that is open loop control systems. So closed loop control systems means control unit, error signal will be there, driver will be there, one motor will be there. How that motor is going to be worked, and I am going to taking the feedback again I am going to giving to the control unit. Whereas open loop control system, there is no feedback element. So open loop control systems means without feedback. Closed loop control systems means with feedback elements. Now we will see that another slide. So best example for that closed loop system, automobile steering systems. See that desired output will come, error signal will be there, and after that driver is going to be taking. After that driver will segregate that signals. After that steering mechanism will be there. It is controlled by the driver. After that automobile is going to be running, means that engine is functioning. After that output will go that actual how much speed we are going to accelerating that accelerator pedal. So after that it is going to be coming to that feedback element, so that visual how much speed is going, means measurement and all the things visual we can see that whether it is we want to stop or not. Visually we are going to taking feedback, and if it is an error will be there, we are going to sending to the error element. So here I am going to showing that one graph over there. Direction of travel x-axis, and x-axis is the typical direction of travel response. After that y-axis is that direction of travel. So over there here two things. So started that a car is started, it is going, any up and downs will, any stones, any obstacles will be there, it will be stopped. So that the curve is going to that like that. So that observed is blue line, and actual it has to go by block line. Okay, so desired direction of travel we are going to showing by block line, and the actual direction of travel we are going to showing by blue line. Okay, By observing this also, what is the difference between that open loop control systems and closed loop control systems. So automobile interior also we can see that one of the example taken, so that thermostat will be there, controller, that is the desired output, desired temperature will be there sent by the driver. So cooling system here, thermostat will be there, and air conditioning unit will be there. It will be control how much temperature we can give it to that cabin. After that it is going to be that process in that automobile cabin. If it is correct 18 degrees centigrade, that cooling effect temperature is 18 degrees, it will okay, it will go for cabin temperature. If it is not there, it will go to take that temperature sensor, means that feedback element. Here is feedback element is that temperature sensor. We can sense it, and after that how much we want to send 18 degrees. If it is more than, suppose say that it is going by 16 degrees centigrade, again we can the error signal will take and it will send to that thermostat, it will send to that cabin. After that processing it, after that it will send to that 18 degrees centigrade. That 2 degree temperature will add and we will send it to that. Okay, that's a very clear examples of closed loop control systems. Okay, here we are going to one more in this control systems, servo mechanisms. Servo means, what is a servo? Servo, we are going to serving that mechanism is called as servo mechanisms. So it is automatic devices, error sensing, and it will sense that negative feedback, after that perform that mechanism. Okay, so generally it is defined as servo mechanisms. It is an automatic device. Particularly servo mechanism is that automatic device, and then it is uses for sensing that negative feedback. That's very most important. Negative feedback it will sense and it will correct it. It will correct it, and whatever mechanism required by that machine, that mechanism going to be given to the machine is called as servo mechanisms. So generally this servo mechanisms includes that built encoder. One encoders will be there. Using that encoders we are going to sending that these mechanisms. So whenever this feedback will be there, or error correction will be there, with the error corrections and feedback only we are going to correcting that mechanism of mechanical positions, either speed or pressure or example, so many examples are there, velocity. Okay, all these things with the help of only servo mechanisms we are going to controlling. So that cars cruise control issues, closed loop control systems feedback, and it is going to be installed by that servo mechanisms only. Okay, right, with this slide I am stopping. So next slide we will discuss this servo mechanisms. Thank you.